And you can do the same thing with LFOs, of course. So each LFO has its own assignment button. No, I didn't. I was assigning LFO1 to modulate its own rate. That's not very useful. But you can do that. And of course, you can also have the rate of it. Oh, I did it again. All right. Hey, there we go. So yeah, I've got LFO modulating the frequency of oscillator 3, and I think its own rate as well. All right, so that sound reminds me that we haven't started filtering anything yet. Yes?
I'm sorry, but before you leave the oscillator section, I'm coming from Omnisphere, and something that's unique, well, not unique, but something that's common in Omnisphere is I can change whether the phase of the oscillators begins all at the same time, or whether it plays through the oscillator at different times, or whether it's just random. Can you do that on the Moog? Or
yes, not necessarily with exactly the same specific options, but by default, the Moog 1 oscillators are free running. So there's no relationship between their phase and when you play a note. But you do have the option to turn on note on reset.
Oh, cool.
And so that lets you start the phase of the oscillator when the note starts. And especially if you're doing things like, sequenced bass lines or anything that's like really punchy or rhythmic, where you want the attack of each note to be a certain way consistently, then resetting the phase of the oscillators gets you there. So yeah.
Thanks.
Yeah, you bet. Yeah, so there's one more sound source that I haven't discussed, which is noise. And on most instruments that have a noise sound source, basically you get one flavor of noise, and that's what it is. And maybe if you're lucky, it's pink noise or something useful like that. But it's just noise, and then you run it through a filter, and maybe you apply an envelope to it, and that's what you get. In this case, we have a really flexible noise generator. We wanted to have a lot of different flavors of noise. So there are 3 basic noise filters in here that give you red noise, white noise, and what we call purple noise, which is really emphasis on the high frequencies. And so that has its own dedicated color selector and a color mix control that lets you crossfade between any 2 flavors of noise that you want to get the in-betweens. So that's a red noise, and it's mostly low frequency. Emphasis is on the lows, and you can crossfade between that and a white, say. So there's your white noise, and then you have purple noise. You can crossfade between purple and red or purple and white. So. And so as you can imagine, that gives you a lot of sort of aesthetic possibilities for, just for noise washes itself, and also just for adding little components to the sound. There's a dedicated envelope generator right in the noise section, so that you can have, if you want just like a little noise hit as a part of your sound, you don't need to waste one of your main envelopes to do that. It just has one built in. So if I want a sound that has just like a little chiffy attack at the beginning, that might not be exactly the most useful thing, but especially like for percussion, for winds, for all kinds of sort of organic sounds, you do either want a component of noise, throughout the body of the sound, or just at the attack. And you have that option here. You can also, you've got long ranges for the attack and release, so you can have variations. And there is also an external audio input. There are actually two external audio inputs. There's a XLR and quarter-inch combination jack with a mic preamp, and then there's just a basic line input, quarter-inch line input. And each of those both exist in parallel, and they can be switched into the mixer independently per part. So if you're talking about a multi-timbral sound, you can actually have one of your virtual synths processing one of those external inputs and a different layer processing the other external input, just by switching which one of them is switched into the mixer on which layer. So the mic input can feed the vocoder models that also exist in here, which I can dork around with later potentially. It's not the most exciting thing about the instrument, but it's in there. If we're going to build a crazy analog synthesizer with digital effects, should probably throw a vocoder in there, so we did. Yeah, so that is, oh gosh. All right, yeah, hey Andre. That's the sound sources. And so I talked a little bit about the LFOs. Let me talk just a little more about the LFOs, and then I'll get into the filters. I'm excited to talk about the filters. But the LFOs are very full-featured. It's another case of freedom. All right. It was another case of sitting down and drawing out, like, what is everything that I want an LFO to do? And this is most of it. It's not all in there, but it's mostly in there. So to start with, basically you have your waveform selection, and the basic families of waveforms are, you've got a triangle, a pulse, a sawtooth, and a sample and hold. But each of the basic waveform types is continuously variable. It has a continuously variable wave shape. So you can crossfade continuously between the triangle and a sine wave. Or the pulse wave has pulse width modulation, the same as the oscillators do. And the sawtooth LFO is continuously variable between a sawtooth and a triangle and a ramp, just like the audio oscillators. So I guess probably the polite thing to do would be to demo that. So let's do. There we go. Let's see. Modulations going on here. I'm going to delete most of them.
Too many.
Too many for demonstration purposes. Alright, there we go. Nice, simple sawtooth LFO. Maybe a little slower. Alright, so there we go. So that's triangle. So, yep, continuously variable. And the sample and hold waveform is continuously variable between sample and hold and noise, which is kind of fun. You can have noisy sample and hold or slightly steppy noise. And also you have smoothing. Any of the waveforms, any of the LFO waveforms can be passed through basically a simple low pass filter to add some slew to them. So you get a lot of options there. So additional controls that you have in the LFOs include you can set the start phase, so and you can have it trigger on node on, so you can have an LFO that lets you set exactly where in the cycle it's going to start relative to each node. You can clock sync them, and you got a lot of options for the timing and clock divisions of the sync. And you also have a delay time and fade in and fade out time, so you can have an LFO that comes in just at the start of the node and then fades out, or it only comes in after you've been holding a node for a little while, things like that. So I'll add some delay and some fade in time. Or some fade out time. So that's for like 10 seconds. That might be a little bit long. And you can also set it to an integer number of repeats. So you can have like just 4 LFO cycles and then it'll stop. Get rid of the delay time and the fade in time. Yep, lots and lots of utility for that. It's great for like little trills and things at the beginning of a note. That might even be the best shape for it. Oh, and still got some smoothing on there. Lots of
LFOs did you say there were per engine?
There are 4, and those all exist per voice. So each voice has its own 4 LFOs. If you don't do anything to modulate the LFOs per voice, it'll act like one LFO, basically. But if you do things like apply velocity or pitch or any other modulation source that is unique per voice, then those LFOs will go off independently from each other, and you'll have independent rate per voice. So let's see if I was to turn that back to infinite repeats and do something like have key pitch modulate the LFO rate, like so. So you have a lot of independence for those modulators.
Are all 4 LFOs the same, or is there different? Or they have different feature set?
No, they're each basically they're 4 instances of the big LFO module with all the parameters. Yeah, none of them have unique things that they do that the other LFOs don't do. All right, and it's basically the same with the envelopes. They are all freely assignable as modulation sources, the way the LFOs are. The way the modulation system in this works, I mentioned that you basically press a button and you turn a knob to assign a source to a destination, and every one of those that you create is you can review and tweak all of those in the mod matrix, which is displayed on the LCD in the center panel. And right now you can have up to 20 of those freely assignable modulations per layer, per temporal part. And that's a conservative estimate. Probably we can add more because those are defined in software. So once we figure out how many modulations this thing can do simultaneously without falling over, we can increase that number. Could be in the hundreds one day. I'm not entirely sure what the upper limit is. Some modulations are more expensive than others, and that's one of the reasons that it's tricky for us to, we don't want to create a situation where you're tweaking and you're tweaking and you're tweaking, and then you just like run out of CPU and the thing packs up and does something weird, because that's not a very analog synth experience. So we want to make sure that people don't have that like, oh no, my computer music machine crashed experience, if at all possible. But yeah, even so, 20 freely assignable modulators per layer it's enough to do some damage for sure.
How do you test that, in-house or do you go selection public?
Pretty much in-house. At least to begin with. We have people that we have friends and family that we've been working with for a long time. So before the public release, there were a handful of people outside of Moog that were test driving it and checking it out. But it was, it's pretty much just like by special arrangement, we would send them an early prototype and get their feedback, or even go to them and work with them one-on-one, to get their feedback on that. We have our own in-house QA person who's like incredibly skilled at thinking of really stupid things to do with a synthesizer that nobody would ever do, but someone has to try it because it's going to break and you won't know unless you try it. So we, there are people whose talent that is. Yeah, it's fun, but it's also maniacally detail oriented. I could never do it. I'm just not that focused.
Is there like a CPU meter that tells you?
Well, not right now. We've thought about that. That is actually a matter of philosophical debate. There are people who think that putting a CPU meter on your analog synth is just like not cool. It's not an okay thing to do.
You call the analog level.
I was trying to think about that, like, available magic.
On analog. Yeah, there you go.
Oh, darn, I'm out of magic. I'm gonna have to start a new patch.
Thermometer on it.
Yeah, you could do a thermometer. That's not bad. But then again, there's actually heat management, like actual physical heat management, is an issue. The DACs in this, there are a ton of DACs generating all of the control voltages, and a ton of processors. There are actually, there are more processors in this analog synthesizer than you can shake a stick at. And that's another reason, because it is like, ultimately everything that you hear is analog. The whole signal path outside the digital effects is analog. VCOs, VCFs, VCAs, all that good stuff. But, as I said, it's riding on top of a ton of digital technology. And so anything that highlights that digital nature is like, it's there and it's real, and we're not going to pretend that it's all analog elves running around in there and there's no computers involved. But some people balked at a CPU meter, so the debate continues. Ultimately, if having a CPU meter is the thing that's going to let you unlock having 100 modulation slots until you run out, then bring on the CPU meter. As far as I'm concerned,
Yeah.
I think that's great. But we're working it out. Yeah. Oh, well, there you go. VU meter.
There you go.
Oh, you pegged your VU meter. You got to stop adding modulations. I like that. That's good. But you might see that in a future edition of the one.
A CPVU meter. Yeah.
Yes. Okay. So, all right. I want to talk about the filters. I've been waiting to talk about the filters. There are 3 filters per voice, and they're in 2 sections. There's the classic Moog transistor ladder filter that every Moog synth is contractually obligated to have one of, and they really do sound good. It's not like we're not sad about putting them on there. But additionally, on this instrument, because the thing about a ladder filter, especially if you only have one filter, is that it does certain things really well, but it only does those things. So 2 things. One thing it does really well is liquidy smooth filter sweeps. Let's see, I'm going to reinitialize again because I got into a weird place sonically. So that's basically no resonance, just a low pass filter, doing what it does. And the other thing about transistor ladder filters is that when you increase resonance, you lose bass frequencies. Actually, the energy that had been in the bass gets moved up to near the cutoff frequency of the filter. So you can hear there's a lot of low end with no resonance. Not as much low end with high resonance. But it's kind of worth it because what it does with that energy when it puts it up near the cutoff frequency is really, really nice. So that's kind of your classic Moog filter thing. But on a polyphonic synthesizer, one of the other things about having just a low-pass filter is that if all you can really do is trim the highs and you're playing a lot of notes, you end up with a lot of mud, you end up with a lot of low mids, you end up with just a lot of murk in your sound, which is great if you want it, but it's not always what you want. So I was really keen on making sure that we added a state variable filter to this. And this is an OTA-based state variable filter that is, it's an original design, more or less. It was designed and voiced in-house, but I would say it was inspired, at least in principle, by something like the Roland Jupiter 6. So the Roland Jupiter 6 uses an OTA-based state variable filter. It's got bandpass, notch, high pass, low pass modes, and it does this thing with the resonance that is really unique. It's just like this little laser beam that picks out certain harmonics, and they pop out really strongly from the mix. And so we put both of those types of filters in here. And in the mixer section, there are some buttons, there's switches for the state variable filter and the ladder. And what those switches are doing are switching each sound source individually to where it's feeding one filter or the other filter, or both. And so you can take the same sound and send it through both filters, either in series or in parallel. So this is, that's the ladder filter. And if I bring the mix over here, this is the state variable filter. So it's currently in high pass mode. And that's not even quite all the resonance, I don't think. And so it also has band pass and low pass and notch modes. Turn the mains down just a little bit. That's what I was saying about just the harmonic series. You can really hear it emphasized really strongly as that filter passes, emphasizes each of the different harmonics as the cutoff frequency of the filter lines up with the harmonics that are already present in the signal. And actually, I'm not even getting the strongest effect of that. I mentioned that I did mention there were 3 filters per voice. So there's one ladder filter, and there are actually 2 state variable filters. And the state variable filters have a 12 dB per octave slope. They're less aggressive, less steep than the ladder filter. But if you put them in series with each other, then if they're at the same frequency, then it basically you can get like a 24 dB per octave slope by putting those 2 filters in series at the same frequency. And so there's a setting for that here. And if I put them in series, you can really hear the harmonics popping out when I do that. And that's just really, really fun to modulate. It's fun to dial in and emphasize just a certain tonality that you want. And so now I've switched back over to the ladder filter. And you can blend between the 2 of them. And you can run them in series with each other as well. Those filters were in parallel, now they're in series. And by adjusting the relative cutoff frequencies and feedbacks and resonances and mix, you can really dial in a lot of different tonalities. Subtractive synthesis, the basis is you start with a bunch of harmonics and then you just keep the ones that you want and subtract the ones that you don't want using things like filtering. The ability to have multiple different filters with in different modes, like a notch filter can just, if you've got one resonance that you don't like, you can dial it out with a notch filter, and then you can use your ladder filter to do your like classic envelope-y sort of filter sweepy things, and you have just more tools at your disposal for fine-tuning your sound. And they can be modulated differently from one another. Take this LFO and apply it here. Maybe a little bit less of it. So again, not so much doing brilliant sound design at the moment, so much as just pointing at things and talking about them. But it doesn't sound terrible.
So within a timbre,
Yeah.
you have more than one oscillator,
Yes.
and then you have more than one filter,
Yes.
and you can route. Do you have to mix those oscillators and send the whole kit and caboodle to the filters, or you can route them separately?
No, let me do that right quickly. So here I have oscillator 1. That's just oscillator 1. And it's going to a bandpass filter. Whoa. Yeah. All right, and now oscillator 2 I'm going to send only to the ladder filter. So I got some LFOs running around that aren't necessarily helping my demonstration very much. There we go. All right. So there's one sound source through one filter, and a different sound source through another filter. And you can do that with, with your other sound sources as well. You can send them to just one or the other or both. Another nice thing about that is if you have the filters in parallel, you can even use the crossfader between the two filters to dynamically change the mix of the sound sources that you're hearing. Another nice thing about that is that if you've got a particular sound that you really like that one filter happens to be doing, I don't know if that's it or not, but at any rate, if there's something missing from the harmonic spectrum, like you need to bring in a sub bass that's not there, you can take a different oscillator, send it just to the other filter. It doesn't disturb anything about the cool mix of sounds that you have that's sort of the primary characteristic of your sound, but you can just do some subtle tonal sculpting or subtle additions using an oscillator sent to the other filter that's not the main one that you're using.
Can you send it bypass the filters entirely?
Not exactly. In my original design, you could do that, but that was deemed to be too expensive. There were too many extra analog switches that you needed. It already takes a bunch of analog switches, like at least 2 per sound source and mixer to go to the 2 different filters. What you can do, depending on the type of sound that you're creating, for example, if the sound is primarily based around just one of the filters, if it doesn't depend on the interplay of the 2 filters, you can just open the other filter right up and send an oscillator through it, and it's effectively unchanged. The only thing that you can't do is have both filters doing filter stuff and also have a completely unfiltered oscillator going directly to the output. Although, now that I think about it, that is the case with one voice, with one layer. But when you start to get into layered sounds, you could absolutely create a stacked sound that uses 2 different timbres. One of them has all your filtery stuff, and the other one has just like a triangle wave with no filter on it going straight to the output on another layer. So you do have that option there thanks to the multi-timbrality.
I have a question.
Yes.
You've been talking about this for about an hour. Do you need anything? Water?
Yeah, water would be great. A little bit of beer, but water would also be nice. Thank you. Okay, so let's see. I think the only thing that I didn't mention yet about okay, now there's stuff I didn't mention about the filters. You have a lot of modulation options for the filters, sort of hardwired down here at the bottom. You have a dedicated envelope amount. No, I'm good. I'm not sure what the upper limit is of how many hours I've stood in front of synthesizers talking about them, but it's very high, like probably at least 8 hours straight. Trade shows, yeah. NAMM show, yeah. Yeah, typically. Now I've now sort of like I've risen through the ranks to the point where I don't lose my voice completely from talking every NAMM show, but yeah, suffice it to say, I can stand in front of a synthesizer and talk about it for a very long time, fear not. All right, so the other things that the filters can do is they have dedicated FM routing, so you can modulate the frequency of any of the filters with any of the oscillators, and you've got control over that. So let me go back to this nice bandpass filter that I have here. Gosh, I do like that sound. And so if I turn up the FM amount, let's see. So we are listening to oscillator 1, and so I'm going to use oscillator 3 as my FM source.